Hello, everyone. So, my name is Alexey Buzdin. I come from Riga, Latvia, and what basically I do there? So, I try to organize things. I'm a GDG organizer, Google Development Group. I'm organizing Java user group as well, and also one of the biggest conferences in Baltics, Riga Dev Day. And right now, I've started working in a bank called Citadela, and trying to develop and improve some stuff there, and make the bank fun again. So, what I'm going to talk today about? It's marvel of annotation preprocessing. And first question is to you. Who has worked with any tool that used APT, annotation preprocessing? OK. So almost more than half of you. So what the talk will be about? First, what the heck is annotation preprocessing? Why the heck do I need annotation preprocessing? And how the heck should I use and create our own annotation preprocessor? And when we'll cover all this part, we can a bit look into the most familiar and famous frameworks that use APT, like Dagger, MapStruct, Retrofit, and Lombok. By the way, who has used Lombok? OK, this is great. So you'll have a lot of great information at the very end of the presentation. And to start, I'll start with a quote. Developers love to write code. Are you agree with it? Yeah, so I would say no one says this. Why? A lot of people say stuff like this. Developers love to solve complex tasks because we're all about the challenge. We like to solve them. And probably you think this as well. So our aim as a programmer is to not write boring stuff, but write cool stuff. This is why we're choosing libraries instead of writing it yet again in plain Java or Kotlin or whatever. And let's make an example. So CRUD. I know that a lot of you have written a lot of CRUD during the years. Me too. And if I would think about it, how could I write it easier? So I started to imagine, OK, I need a web service that exposes XML and JSON, and it has a couple of resources with a couple of fields. How could I, with a little amount of verbosity, in any programming language, just write it? And I imagined, OK, so a declarative style would be super. I just say I need an API. I have type XML and JSON. I have two resources, clients and payments. I have read access to clients. I have read and write access to payments, because everything is declarative, like in Maven or Gradle. Yeah? So you have default config. And we just say that entity has client ID, full name, email. And that's it. We need a connection to a database. We say, here we have a database. If we want to add an authentication, we can just say, OK, connect to our LDAP. So this is basically what we would dream of. This is how writing application would be fun. We'd just say, OK, I want this stuff, do it. And actually, in practice, we'll write a lot of boilerplate code. So if we would like to write a server, a web service, first, we'll need to write some routing, like which kind of resources will be accessed. Then we'll need to write logic based with XML or JSON. Do we need to deserialize it from JSON, serialize it to XML, etc.? Then we need to build responses. If we're writing RESTful application, we need to say, OK, I will provide this status code. I need this header. I will read this header, etc., etc. A lot of boring stuff. And early in the days, people would write it like this. They have a simple servlet. They have a method. And all the logic is written here. All the boring boilerplate logic. So next, if we have this part of routing, we would need to write some validation logic and maybe mapping from the main transport objects to the main objects, and vice versa. For example, you have a model that is saved to a database later, or you have some other model, you need to map it. You need to do validation logic. If the amount of money transferred is below the amount on the bank account, etc. So next, we need to construct queries. Again, this is boring. We need to write selects, inserts, etc. We don't want to do this, right? And most of the frameworks are doing just like this. They are trying to limit and eliminate at all writing boilerplate logic, like Hibernate, which eliminates parts of writing boring SQLs, like Spring, which right now has everything you need to eliminate most of the parts of boring stuff. For example, routing. If you use Spring MVC, you can just say, I want this, go here. That's all. Dependency injection. We have GUIs. We have Weld also. It tries to minimize JSON, serialization to JSON. Yep. But the problem is, this kind of frameworks are using either reflection or runtime code generation. And first question is, what do you think? Is reflection slow? What do you say? Yes, no, doesn't matter. All the correct answers. And here is a snippet from Oracle specification. What do they say? They say that, of course, reflective operations have slower performance than their non-reflective counterparts. Duh. OK. But does it really matter? It really matters only if you use it frequently in performance-sensitive applications. And usually, if you use reflection wisely, you can only affect, for example, first run of some kind of logic. You have the handler to a method or to a class, it is cached, and then it's fast. But if you go to Android, things get complicated. And here's a report, for example, from NimbleDruid, which is a company that is doing performance analysis for application, where you can submit your own. And they're saying that one of the main problems with this kind of frameworks, for example, JSON, is that it drastically increases startup delay when you start up an application. And 700 milliseconds for a server application in Java, it doesn't matter. OK, you can do it 2 seconds. In our bank, to start up an existing internet bank is about half a minute. No one cares. OK, half a minute, we can just drink coffee. But if our Android application would start up in half a minute, I think someone would spot some problems with this. So what is the recommendation from, for example, Jake Wharton? That try to look into reflection, and possibly you can rewrite it without reflection to be more performant. You can read the whole article here. So in Android, reflection is a matter to deal with. So you need to look into it, and you can improve your application by removing reflection whatsoever. Next up, we have code generation. And code generation is another great tool which generates Java bytecode during runtime. And a lot of dependency injection frameworks in Java, for example, GUIs or Weld, they're constructing the bytecode during runtime. And first time when you run this application, this code snippet, it will be a bit slower. But then when the bytecode will be constructed, it will run the same speed as the normal code. But what's the problem? This not always works. Where it doesn't work, it doesn't work in this kind of applications. GWT, Android, Java to Objective-C compiler, RoboVM. So all those applications that are not using Java runtime, not using Java bytecode. And those frameworks are a bit different in the regards. For example, GWT, GWT is using Java sources. Android theoretically uses Java bytecode, but then it compiles it to DEX files. So again, it will not work. RoboVM is a great tool, but sadly it's gone now. So rest in peace. Was also using another runtime for this. So all the frameworks that is using code generation, which is quite popular in Java world, are not able to run on Android, which is bad for us, and we need to find an alternative. So this, when we get to annotation processing. And what this basically is, annotation processor is a tool that generates classes during compile time. So we are safe with all those frameworks, with RoboVM, with GWT, with Android, etc., etc. Because all the magic that Android does with its compiler can happen after annotation processing. And let's try to write our own annotation processor, just to see that it's quite easy. So it isn't magic, it's magic, but it's the same as you're writing reflection. So if you have ever written a reflection code, you would easily write and understand annotation processor code. So how? First thing, there is a great article about 101 of annotation processing, which drives you through the whole process of creating one. But first, you need a class, as always, for your application. So this one is the class that extends abstract processor. And the class will contain 4 main methods. First is an init method. So this is just basically a constructor. Yeah? So every application needs an init phase. Next is a process. So this is where all the magic will happen, and we'll deep dive into it. Next one is get supported annotation types. So this is a method that passes a set of strings that represents what kind of annotation we're working with right now. So for example, Dagger would pass inject annotations, component annotations, and maybe just component, yeah. Component annotation here. So this is a primary annotation when we'll be constructing code. And also get supported source version. So here we just specify what kind of JDK we're working with. So next, this is a pre-cooking process. So we need to have a project. In order for our processor to work, we need to have it in compiled state. And we need to have a meta-inf folder with services folder and with full name of JavaX Annotation Processing processor. So this is just a text file which contains all processors inside this jar. So when Java-C starts, it looks into all its class paths and looks into meta-inf folder. If it sees the processor flag, it runs all the processors inside that file. Yeah? So if we add Dagger, for example, to our class path, it will automatically detect this file and run it. So here, how the magic starts. And this process of annotation processing will run in a separate JVM. So Java-C will start up a JVM to do annotation processing and then continue working with compilation. Also, so this is quite not pretty, I would say, because you just need to manually create a file, put the classes here, and Google, for example, created a library that uses annotation processing to create files for annotation processing. Yeah? So this is called Google Auto Services. So this is basically one annotation which you can put on your processor. It will automatically generate that file. Yep. OK, so next. And it's really hard to try to figure out an example for that. So I've just copy-pasted it from that tutorial that I've showed you earlier. And basically, here, the idea is you have a pizza store, some kind of menu, and you have different kind of meals. And if a user requests a meal, you need to give it back. So what is the problem? The problem is every time that you remove a meal or add a meal, you need to modify this file. You need to add an extra if statement. So if. And we could optimize that. How we could optimize? We could construct this part automatically. Yeah? So we could do it with reflection, of course, but we don't want to. We want to do it with Annotation Preprocessor. How it will look? We want it to look like this. We just have a meal factory, some kind of class that it's automatically constructed. We do create, it does the magic. So let's start. First, we need to have an annotation. The annotation will be called factory. Yeah? So it has two parameters. One is a type, second is an ID. So ID is the key that we'll be passing here. If we ask for salami, we get salami pizza. And the type is a type of class we are constructing. So this would, for example, grant us ability to use factory for multiple stuff, not just for meals, but for meals, for drinks, for something else. Yeah? So we can reuse this factory. OK, so we have this annotation, and we can put this annotation on our Margherita Pizza class, which implements meal. And this, for us, would be everything we need to add this Margherita Pizza to this if statement. We don't need to write anything else. Everything else should be constructed automatically. So now, this is the client side. So now, let's dive into Annotation Processor and how we can generate these if statements we've seen here from this kind of information. So this is, to remind you, this is the processor class with 4 methods. So let's try to fill all those methods one by one. So first, get supported annotation types. This is easy. We have our factory annotation. We just pass it here. So right now, Annotation Preprocessor will try to find all classes with factory annotation in ClassPath, and then process them. Second one, also easy, source version. We just say latest supported, whatever, JDK 9, 10, I don't care. Next one is an init phase. So here, this is basically a constructor, and we can get all the stuff we need from this environment field. What do we need? Let's start from the bottom. A messenger, this is a part where you can post information to the consumer of your library. So if you would like to pass an exception that a user should see in his Java C compilation, you can pass this exception to messenger. So you say messenger.error and pass an error, or info, or a warning. How would you read this name? Any ideas? What is this? Filer. Yeah. So when I first read it, I thought that filer, what the heck? What does it feel? OK, it's a filer. So filer is a class that creates files. Yeah. So if we would like to create a file, we say filer.createClass. It will create it. Element utils and type utils will be a magical stuff, so we'll cover a bit later. So first difference from reflection is that reflection is working on bytecode during runtime. And Java C doesn't know what is happening in your reflection code. In Annotation Preprocessor, those two guys, Gillett and David, written an alternative to reflection called JavaX lang model. And there are an element hierarchy that extends from type element. So basically, they called it mirrors. So what this means, that your class has some kind of element. So we are viewing the source code right now, not the bytecode. And if we view this file as a list of elements, we would see that first we have a package element. So a package element, and then it could have the keyword and the value. Then we would see a type element. So type element in this class. Type element contains inside variable elements, executable elements, so a list of inner children. So then, again, you can go to variable element, and you can get a modifier from it, or a type. Yeah? So this is another view on how you can parse the files, the class files. So these type utils and element utils are just helper classes that will allow you to understand and get the information you need from these element classes. So what next? So first step, we have this process method. And what we're going to do, we want to get from our environment all elements annotated with factory class. So now we get a list of elements, and we just go over them. And the first thing, so why those elements are different here, that we theoretically can get not only classes, we can get a method, because annotation could be on a method, on a variable, on a parameter. And first step, just to illustrate, we can make a check. For example, here, we're saying that the element should be a class. If it's not a class, we're using the messenger to print an error. So this is a compilation error that our annotation was used incorrectly. So what next? So if it's a class, we can already start working with it. So we have the element, annotation element. We know that it's a type element, it's a class. And then we need these values from that type element. So what do we need? We need an ID. So basically, what kind of keyword we're using for our factory generation. We need the simple type name. So this is basically Margarita Pizza, yeah, the name of a class. Also a fully qualified class name, so all the packages, because we'll need the fully qualified class name to construct it, actually, without imports, if we don't want to write imports. And here, in this class, what we can do? We have this element. We already know this is the one, this is a class. And we can get an annotation out of it, the factory annotation. Yeah? And after this, we already can grab all the information we need from the annotation. So here, we just grab an ID. So the first part is already settled. We have the ID. So what next? Next part is a bit trickier. So we have this class element, which is type element. And here comes the tricky part, that when you start APT, you don't have compiled classes. So you cannot use reflection, for example, to get a simple name of a class. Why? Because the source files are not compiled yet. But on the same step, you could have jar files in your class path which are already compiled but doesn't have a source code. So here we have a try catch that first tries to get the class files and get information about the class name from it. If it fails, it throws this kind of mirror type exception, which is specific to Java lang model. And then it tries to analyze the source code and get the same information from source code. Yeah? So this is a bridge between reflection and Java lang model. So after this scary part, we get all information we need from the class files. And then we need to construct the file. So don't read this yet. So this is basically how we can create a source file in our annotation processor. We're using this filer and writing some stuff. And in plain annotation processor, you would have to write strings into files. You just construct with string a full source file you want to be created. But there is a cool library from Square, which we'll analyze right now, called Java Poet, which allows you to do it in a more Java way without actually concatenating strings. So let's start analyzing. So first, we want to have a method. Yes? So a method that will take a string and create a meal. Here is how we can describe it. We say we need a method called create. It should have a public modifier. It should have a parameter called ID with a string type. And it should return a type name get superclass as type name. So we have this parameter superclass name of meal, and it should return. So this is just how we convert with this Java lang model. Yeah? So next step is we need to have those ifs we've seen previously. And how we could do the ifs. So we know already we have a list of all factories. So all the classes that are annotated with factories. So we can just create a for each loop for this list, for each class we found with a factory annotation. And then we can say method begin control flow. So control flow is basically either an if statement or a for statement. And here we say in string that there's an if, there's a first argument equals ID. And we pass the argument. And then inside of this if statement, we say return new and L argument. And here is our argument. So this is what has been constructed. So if there will be 3 classes with factory annotation in class path, there will be 3 ifs here. If 5, 5. So what else do we need to do? So did we generate it as a file correctly, or we still have something to do? For what do we need an import? For meal, for example, yes? So here is a type spec. So here I forgot about the import, to tell the truth, but here we generate as a class. Yeah? So we wrap a method and say we have a type spec builder. We say what name of a class do we need, factory, and then we add all the methods. When we have this type spec, the representation of a class, we can say what package name do we want to put it in, and then write it. So after this step, already we'll have a source file with this information inside this package in a build directory. So that's it. We generated a file. And to make it a bit more complicated than this, that this process method is running all the time. So it has rounds of processing. Why? Because you can generate code which also has annotations that you need to process. For example, you generate some dependency injection code which also has injects inside of it. So here, the first round would be, it would take all these items with factory annotations, create a meal factory. Then it will take meal factory, all the files that were generated during the output and not processed, and try to create something. It created nothing, so that's it. The source round is not running right now. Yeah? And to actually test this thing, there's also a Google library called compile testing, which allows you to use their truth library to try and compile some kind of source code. So here we say that there is my class in our class path, in our source, and we say, please use this processor and compile it. And then you should have a generated source file called myGeneratedClass, and you can do all kinds of assertions here. Also, you can pass just a string to compile, so you're not limited to actual classes. Yeah? And that's about it about Annotation Processor. So it's a tool that allows you to build classes during compile time, which could be handy for you if you need some parts to be done automatically. And now, let's look at stuff that already uses annotation processing inside of it. So we could understand what kind of things we could build our own with this annotation preprocessing. For example, Dagger 2. So who has not worked with Dagger 2? Please raise your hand. OK, a couple of people. So all of you know Dagger 2. It's awesome. It has its problems, but has its pros. So it is now the fastest Java dependency injection framework. Why? Because it doesn't use reflection, it doesn't use code generation. And basically, to repeat, what does it do? You can have a class, you can have inject annotations, and then Dagger will inject correct instances into that inject annotations. How can it do it? We have a component, we have a module. A module describes what type of dependency bindings do we have. The component is an endpoint and access point to this dependency. So we have this coffee maker that we need to get. We have this component that allows us to get the coffee maker. And here is the generated class, Dagger Coffee Shop. So this Dagger Coffee Shop, our component, is generated with APT. So from the knowledge that you right now know about annotation preprocessing, we know that they are scanning the component annotation and then constructing all the magic with it. So now it looks quite simple, right? So at least we know how it works. So what else Dagger provides us? Singleton and scope bindings, some lazy injections, provider injections, and different qualifiers. So what next? There's another tool called MapStruct, which could be a saver for you in Java world, not that much in Android world. And what basically it does a bin mapping. For example, what do we want to do with a bin mapping? We have a car, class car, and somewhere we get a car and we want to do a car DTO. And usually you would need to write set, get, set. This could be done automatically, and MapStruct does it. How does it do it? You annotate the car mapper with a mapper interface, and then you can get an instance of this mapper from mappers.getMapper and provide the class of the mapper. Yeah? Okay, 5 minutes. Okay, so basically here you can add mappings if you want to customize something. For example, if you want to have different names from source, from target, etc. Yeah? So this could be very effective for you if you're writing Java applications. So Retrofit, again, cool library, and it also uses annotation preprocessing. So I think most of you have worked with it. So here they have this get annotations, which they are get, post, etc. And they are getting this interface and creating a source file for that. But we don't work with it because it's somewhere hidden inside the builder class in Retrofit. So there are all cool stuff in Retrofit, and maybe the last one that I promised, the sugar on top, is Project Lombok. Project Lombok also uses some parts of annotation preprocessing, but it's more intelligent, so to say. And what does it do? It allows you to write this kind of stuff, annotation toString. And it will automatically create a toString method in this class. Cool, right? And what Lombok does that other annotation processing do not support, that here the compiler, the processor, updates the class files of this particular class. So it doesn't create new files, it updates the existing ones. Annotation processor can only create new files, so they hacked somehow the JavaC compiler, some kind of process in there. Also, there's annotation for equals and hash code. So you just add an annotation, you get an equals method. And some of my friends are using this in Android, for example, and they're really satisfied with it. So if you can't use Kotlin, for example, you could use this kind of magical stuff in Java to make it less verbose. Next, you could create constructors with annotations. You could say that you want to have an all-argument constructor with annotation inject. And you don't need to write all the inject annotations on all the properties. There's also data and value annotations. For example, data annotation is a mutable Java bin with all the getters, setters, hash code equals, toStrings. Value annotation is the same, but it's immutable. So it has final all over it. So next, what can you spot here? What does Lombok adds to the language? Who can spot it? Val, yep. So already with Lombok in Java, you can use val. So this is how they messed up with Java and what kind of cool features they are providing. Also, if you worked with .NET, they have extension methods. You can have extension methods in Java with Lombok as well. So really cool feature. And the best thing I like in Lombok is that with one config file, you can say that all fields are private. You can even say that all fields are final by default. So one config file, everywhere in your source code, all the package modifiers are private. What else? It has annotation for builders. It has annotation for loggers. If you're using log4j, slf4j, logback, they have different loggers for that. They have delegate methods, etc., etc. So take a look at Project Lombok. Also, what kind of different frameworks, less notable, you could construct? For example, event bus. So there is an event bus completely generated for you. So you just say, here I'm subscribing, here I'm publishing, everything else will be generated. Also, there are ORM already implemented in annotation processing, so you don't need to invoke all the reflection magic on your active Android or any other library. So if there is no library with annotation processing for your particular needs, you can always write it. Now you have the knowledge about it. So what is the conclusion? So annotation processor is powerful. It's fast because it's simple Java code, but it's sometimes brittle. Because with annotation processor, you'll have problems with build systems, you'll have problems with IDEs not recognizing these generated sources, and you'll need to solve them. Yep, it's possible, but it's not the best way. But sometimes it's a lifesaver. If you want to get rid of a JSON, for example, this login square is a library that does the same stuff as JSON. So it generates JSON bindings, but in compile time. So it won't affect your startup speed. And the main idea is that use it wisely. If you need it, if you want to improve your application, maybe annotation processor would be a good fit for you. If not, then don't use it. OK, so thank you. And right now, if you want, there are some time for question and answers. Thanks. So any questions?